Hey everybody! So today we're learning about the different types of bonds. There are three major types of bonds that we're going to learn about in honors chemistry. There are covalent, ionic, and metallic. Covalent bonds occur between non-metals. So if you see a metal in there, you immediately know it's not a covalent bond. If you have the name, remember that covalent compounds use those prefixes in the names. So things like carbon monoxide or carbon dioxide, that's going to be another clue that you're dealing with a covalent compound. Covalent compounds happen when the elements have an electronegativity difference of less than 2.0. Electronegativity is something that you're going to look up on a chart. In order to find the electronegativity difference, you're going to look up the electronegativity of both things, and then you'll just take the bigger one and subtract the smaller one. I'll make another video for that. If the electronegativity difference is less than 2.0, then it's probably a covalent bond. In this class, we're just going to say it is definitely a covalent bond. And in a covalent bond, the atoms are sharing electrons. So let's say that we have a hydrogen atom right here with one electron. And you guys should know by now that hydrogen wants to have a full valence layer. It wants to cosplay, or it wants to look like helium. That's going to make it more stable. So it wants to have two electrons. Here is another hydrogen atom with its one electron. Each of these hydrogen atoms is going to tug at the other atom's electron. The pink one wants to steal the black electron. The black hydrogen atom wants to steal the pink electron, but they're the same element. Therefore, they have the same electronegativity. Neither one is stronger. Neither one wins. So what happens is they actually end up sharing. The electrons end up spending a lot of time in between the two atoms, being shared between the two atoms. The pink hydrogen atom is now touching two electrons, which makes it stable. That makes it happy. It has a full valence layer. And the black hydrogen atom is touching two electrons. It's more stable. It has a full valence layer. This is a covalent bond. Those electrons are being shared. That is not always the case, though. When you have ionic bonds, those form between a cation and an anion. Remember, cations are positive, all right, and anions are negative. This is often going to be between a metal and a non-metal. As soon as you see a metal and a non-metal, you immediately know it's ionic. Be careful, look for your polyatomic ions also, because those are very commonly some of the anions we're going to see. The electronegativity difference will be high. It will be greater than 2.0. With ionic compounds, what we see happening is that electrons are actually transferred. So let's say that I want to make this match something later on. So let's say that I have a chlorine atom right here, and I have a sodium atom right here. And if we draw the Lewis dot diagram, you should know that chlorine has 7 valence electrons. I'm going to move my sodium over here just a little bit. And my sodium has 1 valence electron. The chlorine is actually going to steal that electron and drag it all the way over to itself. That means the chlorine now has a -1 charge. We normally write that -1 outside, but I kind of ran out of room. The sodium lost that electron, so it now has a +1 charge. The positive and the negative are attracted to each other. So these things are now attracted, and they're stuck together in that positive-negative electromagnetic connection right there. The electron has actually transferred. These are very, very strong bonds. Covalent bonds are fairly weak. It is hard to break ionic bonds. Therefore, if you want to melt something, it has a very high melting point. All right, you've got to put a ton of energy into this thing before you can break that bond. Covalent molecules, on the other hand, those are weak bonds. They're easy to break. So they have a very low melting point. The last thing we're going to talk about are metallic bonds. Metallic bonds form between different metals. So it could be a bunch of, I don't know, copper atoms, or you could have copper and tin atoms mixed together, right? It can be one or more metals, it doesn't matter. When we have metallic bonds, you end up with positive metal cations floating around in this sea of electrons. I always explain it as, think about the last time you were at a public pool. There's a whole bunch of people, those are sort of like the metal cations, and they're all floating around in the water. The water is sort of like that sea of electrons. The people can move and flow, and the water can move and flow. Well, the cations can move around, and the electrons can move around. That's why when you smack a metal with a hammer, those cations can just smush and move so the metal doesn't break. That's why metals conduct electricity. Those electrons can flow from one atom to another, and it's not a big deal. In my class, I asked my students to draw representations of each of these kinds of bonds. So in a covalent bond, we did carbon monoxide. And you can see that the black carbon atoms that are filled in and the blue oxygen atoms that are done just as an outline, those are actually touching each other. They're actually bonded together in separate, discrete molecules. So this would be an example of a covalent compound. When we look at ionic compounds, we have alternating cations, positive, and anions, negative. It looks kind of like a checkerboard, all right? We have this whole big chunk, and they're just all separated out, so none of the positives are next to each other and none of the negatives are next to each other. Instead, they're all attracted to the opposite charge. Lastly, we have metallic bonds. And so one of my students said, let's do copper. So we just have some positive copper anions here floating around in this sea or this pool of electrons. It would be a really good idea for you to stop or pause the video and copy this down to have these notes for your own. The act of copying it really sometimes does help you to understand it a little bit better. In either case, I hope that you understand the types of compounds and the types of bonds that we'll be learning about in honors chemistry. Thank you.